Hello everybody, getting ready to do lesson 4.7 part 2 of pre-calculus math today. Have your class worksheet in front of you. If you need extra class worksheets, email me here. 4.7 part 2, you got 6 points here of your notebook to take, and then 32 points on your class worksheet today. To teachers, today's bell work again is a radical expression here. Simplify it, students. Give your students for these two here, give them about 4 or 5 minutes. Okay, getting on to our bell work here, our solutions for today's bell work. For the first one here, 2 times square root of 3 over 6. These will cancel here and you'll end up with square root of 3 over 3. And then down here, 2 times square root of 2 times square root of 5 over, underneath 5 times square root of 5. And this will cancel here, and then you have 5 over 2 times square root of 2. Rationalize the denominator, and we will multiply this by square root of 2, and then the numerator by square root of 2. That will be 2 times 2 is 4, and this will be your simplified radical from that. Okay, moving on into our first page here of our 4.7 part 2. Other inverse trigonometric functions. The cosine function is decreasing and 1 to 1 on the interval of 0 is less than x, x less than or equal to pi as shown here. So here's our cosine function here, and on this interval here it would be 1 to 1. Cosine x has an inverse function on this interval here. So on this interval here, it would be 1 to 1, so it will have an inverse function. Consequently, on this interval, the cosine function has an inverse function. The inverse cosine function denoted by y equals arc cosine x, or y equals cosine to negative 1x. So to further get into this, because y equals arc cosine x and y equals cosine y, or rather x equals cosine y, are equivalent. So these two functions are equivalent on this interval here. Their graphs are the same and can be confirmed by the following table of values. So here's y, then x equals cosine y. So on these, this table here, pi over 2 for cosine would be 0. So this proves that they do have the same table. They do have the same values in the table, so they are the same graph. Similarly, you can define an inverse tangent function by restricting the domain of y equals tan x to the interval negative pi over 2 pi over 2. The inverse tangent function is denoted by y equals arc tan x, or y equals tan to the negative 1x. And then into your notebook, because y equals arc tan x and x equals tan y are equivalent on this interval, their graphs are the same and can be confirmed by the following table of values. So here again we have our table of values here that confirms that these two arc tan x and x equals tan y are equivalent here. So negative pi over 4 would be negative 1, and etc. here. Pi over 4, or rather pi over 6 would be square root of 3 over 3, and then pi over 4 would equal 1. The following list summarizes the definitions of the 3 most common inverse trigonometric functions. Definition of inverse trigonometric functions. We have function and domain of these things and the range. So y equals arc sine x if and only if sine y equals x on this domain and then on this range here. And then y equals arc cosine x if and only if cosine y equals x, again on this domain and then on this range. And then arc tan x only if tan y equals x. And then this is different here because the tangent function, which we haven't seen yet in this section, goes from negative infinity to positive infinity, and then on this range here. Okay, Page 5 on today's class worksheet. Get all these lines up in here. Evaluating inverse trigonometric functions, finding the exact value of arc cosine square root of 2 over 2. So because cosine pi over 4 equals square root of 2 over 2, and pi over 4 lies in the interval from 0 to pi, it follows that arc cosine square root of 2 over 2 equals pi over 4. And it's an angle whose cosine is pi over 2 would be the exact value of this one here. So it'd be pi over 4 would be your exact value for arc cosine pi square root of 2 over 2. And then cosine to the negative 1 of negative 1. Because cosine pi equals negative 1, and pi lies in the interval 0 to pi, it follows that cosine to the negative 1 of negative 1 equals pi. So the angle whose cosine is negative 1. So this would be pi here. And then C arctan 0, because tan 0 equals 0, and 0 lies in this interval here, negative pi over 2, pi over 2. It follows that arctan 0 equals 0, and angle whose tangent is 0 would be for arctan 0 would just be 0. And then for D, tan to the negative 1 of negative 1. Because tan of negative pi over 4 equals negative 1, and negative pi over 4 lies in the interval of negative pi over 2, pi over 2, it follows that tan to the negative 1 of negative 1 equals negative pi over 4, and that is an angle whose tangent would be negative 1. So it would be negative pi over 4 for D. So let's get into an example here of finding the exact value of each expression without using a calculator. So we have arctan here of the square root of 3 over 3, and then down here would be the arctan of negative 1. So it would equal pi over 6, because tan of pi over 6 equals the square root of 3 over 3, and it is in the interval between negative pi over 2 and pi over 2 would be pi over 6. And then for arctan negative 1 equals negative pi over 4, because tan of the negative pi over 4 equals negative 1, and it lies in this interval as well. Let's go on to another example here. Calculators and inverse trigonometric functions. Use a calculator to approximate the value if possible. So I have arctan of negative 8.45. So arctan of negative 8.45, we're going to use the radian mode on your calculator here. Here's the function arctan negative 8.45 in radian mode, and then here would be your keyboard your entry here, tan to the negative 1, and then parentheses negative 8.45 enter. Then we hit enter from display. It follows that you would get this number here, negative 1.4530, and then sine to the negative 1 of 0.24447. So there's your entry there. We're going to use radian mode, and then this will be how you would enter it into your graphing calculator or any scientific calculator. Sine to the negative 1, and then in parentheses there's 0.2447, and then you would get this number here, 0.2472. And then C arc cosine 2. So that would be your function. Your entry would be radian. You're finding radians here. This would be your calculator entry. Cosine to negative 1 of 2, enter. And we get an error message because the calculator should display an error message because the domain of the inverse function, inverse cosine, is negative 1 to 1. So this is outside the domain here you'll get an error message for that one. So let's try these up here now. Using a calculator, cosine to -1 of 0.75 would be, you should get 0.72. And then down here, sine to -1 of 0.56, you should get 0.59, 0.59.